Hello, and welcome to the Reactor Room, where we solve professional engineering problems in the chemical discipline. In this video, we will solve the following problem. The Reynolds number for a 3-inch steel pipe was determined to be 3 times 10 to the 5th. The fanning friction factor for this pipe is most nearly. Solving this problem requires relating the friction factor to the Reynolds number, which we can do with a Moody diagram. In the Moody diagram, the friction factor on the y-axis is related to the Reynolds number on the x-axis, along with the isocurves for the relative pipe roughness. This is a function of the absolute pipe roughness, epsilon, over the inner diameter, d. Finding the absolute pipe roughness requires knowing the material of construction, and from the problem statement we see that it is a steel pipe. Without additional information, we must make the assumption that this is a carbon or commercial steel pipe. We see that this has an absolute roughness of 1.8 times 10 to the negative 3 inches. And now that we have this value, let's stick with the units of inches for the duration of this problem. Now we need to know and find the inner diameter of the pipe. Again, from the problem statement, we see that this is a 3-inch steel pipe. Without additional information, we must make the further assumption that this is a Schedule 40 pipe. Looking at our piping charts, we see that a Schedule 40 3-inch pipe has an inner diameter of 3.068 inches. So plugging this into our equation, we get a relative pipe roughness of 0.00058, or about 6 times 10 to the negative 4. Now that we have this, we can go back to our Moody diagram and see that this is close to the isocurve for 5 times 10 to the negative 4. So we're going to follow this until we hit our Reynolds number of 3 times 10 to the 5th, which is right here, and that gives us a friction factor of about 0.018. If you were to stop here, you'd see that this is an answer in the problem, and that is incorrect. That is because we were asked to find the fanning friction factor. And the fanning friction factor is the friction factor divided by 4. This is approximately 0.004, which is D, the correct answer. Thank you, and good luck.